Hello everyone, welcome back. This is the second video to our 4-part video about motion. So today we're going to talk a little bit about horizontal motion. Before we begin, we're going to have some key terms we're going to write down right here. And then after we complete that, we're going to have some equations we're going to work out together, and hopefully you'll understand how to work out horizontal motion problems. Okay, so if an object starts at rest, the initial velocity will equal 0. All right, so if the object ends up with x value, the final velocity equals x meters per second. All right, so if the object stops, the final velocity will equal 0. If the object deaccelerates, or slows down, the acceleration is negative. And finally, if no information is given, write a dash on the table. So this one's a little bit more specific to the problems we're going to be working out, and I'll explain that to you as we go. All right, so let's jump right into the problems. All right, so for our first problem, what is the final velocity of a car that starts from rest and accelerates at 7.5 meters per second squared for 11 seconds? All right, so first it asks us what the problem is looking for, and lucky for us in this problem, it's just the final velocity. It says it right there. So next, let's start kind of visualizing what the question is asking. So we have a car. It's my cute little car. And this is the road. And so what we know from our key terms, we know that an object starts at rest, the initial velocity equals 0. So it starts from rest, so the initial velocity will equal 0 for this car. Okay? All right, so we have our car going, about ready to get started. And so it tells us that from rest it accelerates at 7.5 meters per second squared for 11 seconds. So it tells us that the car is going to go for 11 seconds. And it'll end up in this new destination, so 11 seconds. All right, I gotta draw my new car. All right, there he is. Okay, so our next step. So actually, right in the problem, it tells us what the acceleration is in 7.5 meters per second. So for our acceleration, we can just write A equals 7.5 meters per second squared. It's a little small right there, but I'm going to write it in this table too to show you. All right. And so finally it tells us that we're looking for the final velocity. Okay. So the initial velocity is when the velocity begins, and the final velocity is when the velocity stops, to put it very simplistically. All right, so We determined that our initial velocity is 0 because if an object starts at rest, it's going to equal 0. So as for our final velocity, we're looking for that, so we don't know. That's our unknown. Next, I don't see any distance there, so I'm just going to put a dash, as I previously said. We're just going to put a dash if we're not using it in our problem. And so next, our acceleration is 7.5 meters per second squared. All right. And finally, it tells us the time is 11 seconds. So we're going to go back to our pamphlet where we're talking about motion equations, and we're going to look for the best one to fit. So if we look at the second one, we don't have distance included, so we won't use that one. Neither will we use 3 or 4 for that reason. So the best option is number 1, final velocity equals the initial velocity plus acceleration times the time. All right, so I'm going to go ahead and write that down in our equation section. Final velocity equals the initial velocity plus the acceleration times time. All right, so we determined that we don't know our final velocity, so we're just going to leave it as VF. It's going to equal the initial velocity, which is 0, plus the acceleration, which is 7.5, times the time, which is 11. All right, if we get out our calculator, and calculate that quickly, we have 7.5 times 11, which is 82.5, and so 82.5 plus 0 is 0. So the final velocity equals 82.5. So now, we also have to include one of our units here. If we look back at our chart, the unit for the final velocity is meters seconds. So we're going to put ms. So for our answer, 82.5 meters per second. That is our final velocity. All right, let's go on to problem 2 now. So once again, what is the final velocity of a car that is traveling at 12 meters per second and then accelerates at 4 meters per second squared for 7 seconds? All right, so once again, we have to evaluate the final velocity. All right, so if we go in, let me draw my beautiful cars. We have a car, he's sitting here having a good little time, getting ready to go. Okay, so for our car, in this problem, it tells us that the car is traveling at 12 meters per second. All right, so 12 meters per second is going to equal our initial velocity. Okay, and once again, it gives us a length of time it travels. And in this case, it's going to be 7 seconds. And then finally, for our acceleration, it tells us it's going to be 4 meters per second squared. All right, so let's go back to our pamphlet and evaluate which one would be the best one to use. So in our problem, do we have distance included? I don't think so. So we're going to go with number 1 as the previous one. Let me quickly fill that in. Right. And so our equation is going to be the final velocity equals the initial velocity plus the acceleration times time. All right. So final velocity equals 12 plus 4 times 7. And with my handy calculator, I'll punch in 28 plus 12, but I already know it's going to be 40. So VF equals 40 meters per second. So 40 meters per second is the final velocity that the car is traveling at. All right, so for our next problem, it says A ball is rolling along and then accelerates down a hill at 6 meters per second squared for 5 seconds. The ball ends up traveling 44 meters per second. What is the initial velocity of the ball? So, in this equation, it tells us it's specifically asking for the initial velocity. So we put VI, and then, so now let's draw a diagram. So we have a ball, and it's rolling downhill. That's my hill. All right, this is where the initial velocity, because that's where it's starting. And it's gonna go downhill. All right, so I'm just gonna draw this for reference. All right, so in the problem, it tells us that the length at time it takes is 5 seconds. All right, and it also tells us that the final velocity, since right here it ends up traveling, that tells us it's going to be, that's kind of where it's ending. So it's going to be 44 meters per second, which is VF. The I's are unknown. And then it has an acceleration of 6 meters per second squared. All right, so if we go back to our pamphlet, we have to evaluate which equation to use. So, once again, since it doesn't have distance in any of our information that is given to us or that we could figure, we can't use any of the ones that include distance. So our only option would be the first one, which is the final velocity equals the initial velocity plus the acceleration times time. All right, I'm going to quickly fill in our chart. VF is 44 meters per second. The distance is not necessary. The acceleration is 6 meters per second squared. And then our time is 5 seconds. All right, now if we plug our information in, we have 44 equals the initial velocity, which is our unknown, plus the acceleration times the time. All right, so we have 44 equals VI plus 30, and if we subtract both sides by 30, our VI will equal 14 meters per second. So the initial velocity of the ball is 14 meters per second. All right, now finally for our last problem for this video. A turtle is whipping along at 0.25 meters per second, then spots a gorgeous hunk of shell up ahead and accelerates for 6 seconds and ends up traveling 0.65 meters per second. What was the acceleration of the turtle? So, once again, in this problem, it's specifically asking us for the acceleration, so that's what we're going to look for. So, A. So, right now in our little picture, we have a in-love turtle. Yep, that's what he's gonna look like. I'm not the best artist, I'm sorry. And then we have our other turtle who's over here, enjoying, minding their own business. That's some awesome. Maybe a couple hearts will be there because they're in love. All right, so in this equation, so it's whipping along at 0.25 meters per second. So this is going to be our initial velocity. This is where it officially starts. So it's 0.25 meters per second. All right, and then it spots a gorgeous hunk of shell up ahead and accelerates for 6 seconds. So our time is going to be 6 seconds. And ends up traveling 0.65 meters per second. So once again, ends up traveling kind of tells us it's going to be our final velocity. So it's going to be 0.65 meters per second. All right. So now it's asking what was the acceleration of the turtle. So now our unknown is the acceleration. So that's going to be right there. And time is not necessary. So we're going to put a dash right there. All right. Now if we go back to our little equation sheet, we have to look which one does not include distance, and that's going to be number 1. So the final velocity equals the initial velocity plus the acceleration times time. So filling out our equation. So the final velocity is 0.65, which equals the initial velocity, 0.25, plus the acceleration, which we are trying to find, times 6. So we're going to subtract both sides by 0.25, 4, which gives us 0.4, which equals a times 6. If we divide both sides by 6, our acceleration is going to equal 0.4 divided by 6. It's going to equal about 0.07 meters per second squared. So our answer is 0.07 meters per second squared. That is how quickly the turtles accelerate. So in this video, I hope you learned a little bit about horizontal motion, and we look forward to seeing you in the next one. Thank you.